Okay, in practicals, students rolled a 0.505 kilogram cart along a low friction track and measured its speed with a motion sensor. According to the computer, just before the cart collided with the bumper of a fixed force sensor, its speed was 45.5 centimeters per second. The cart then collided with the bumper on the force sensor and reversed its direction. Shown is a plot of force versus time as measured by the force sensor. This is what's displayed on the screen. Here is time in seconds, and here is force in newtons, and there's a jaggedy line there which goes up and then across. The area under the curve, as measured between the cursors, which are marked with the vertical lines there, is 0.437 Newton seconds. From this information, predict the speed of the cart immediately after the collision. Please express your final answer in the box provided to 3 significant figures. Okay, so this is about the impulse momentum theorem, which is equation 9.8 from Knight, which is that delta P is equal to J, where J is the impulse. So J here, in this case, is the 0.437 newtons times seconds, and delta P is the change in momentum. So momentum is equal to mv, so the mass doesn't change, so delta P is equal to the mass times delta V. So we have this equation just looks like mass times delta V is equal to J, so delta V is equal to J divided by the mass. So in our case we've got 0.437 divided by 0.505. Plugging that into my calculator, I get the delta V, change in speed, or the magnitude of it, is 0.86535 meters per second. Okay, so just drawing the quick sketch here to remind us what's going on. The cart was going along at plus, towards the right at 45.5 centimeters per second. And then what happens is it's got this delta V. So delta V is going to be, I guess, negative if we think about it in terms of a vector. It's going to be towards the left. It'll bounce by 100 times that to convert to centimeters. So 86.535 centimeters per second. So the V final was going to be the 45.5 minus 86.535. It's the initial plus the delta, and that equals, it's going to be negative 41.035 centimeters per second. And it actually asks for the speed of the cart immediately after the collision, which is always positive, and it asks for 3 significant digits. So taking the absolute magnitude of that, I get 41.0 centimeters per second.